Hey everybody, it's Mrs. Slauson. So we are going to continue on with 1.1. We're going to look at solving and evaluating in functions. So you have seen this in Algebra 1. It might look a little different though because of how the way it's presented in Algebra 2. And just a quick disclaimer, I am at home, so if you hear any dogs barking, I'll be pausing the video so I can get them quiet, and that's why I'm in my hat. So anyway, let's go ahead and get started. So I'm on page 6 in your notes, and again, we're just continuing our section 1.1, and we are going to be talking about solving versus evaluating. So first, when you evaluate, that's where you're given an x, because x is the most popular variable, and you plug it into your equation, and you start to do the math. You follow the order of operations to find your y. But again, now we're working with a function. So y is going to be replaced with, excuse me, f of x. And you won't just see f of x. You're going to see function notation use some different letters. But f of x is the most popular one. So when you solve, then you're going to use your inverse operations to solve for x, because we have to isolate the variable, and the inverse operations are, for instance, the inverse of adding is subtracting, multiplying has dividing, etc. And then that means we're going to work backwards in the order of operations. So this is how it's going to be presented a lot. You're not just going to work with one function, but you're going to be given several functions. So we've got 4 functions. We've got f of x, which is just a set of data points, some ordered pairs. We've got g of x, which is a graph, a function. This is actually an absolute value graph. We've got m of x. This is another absolute value because of the bars. And then we've got n of x, and this is called a cubic function. So just real quick, this is an easy one to tell. Let's just do a little review. So first, is this a function? So if I look, all the x's are different. So yes, thumbs up, it's a function. And then is it a one-to-one function? So that means all the y's have to be different. So 2, -1, -4, -9, and -16. So just a heads up, this is not only a function, it's a one-to-one function. Now this is a function because it passes the vertical line test. Remember how it hits the shape once? Every time I draw a vertical line, that's a function. But it's not a one-to-one function because it fails the horizontal line test. It hits it twice, here and here, which means that the y value for this point and the y value for this point are the same. And in order to be a one-to-one function, all the y's have to be different. All right, so let's just take a look. So when you see the number inside the parentheses, what I'm asking you is, tell me what my function is worth when x is 2. So what I'm going to do is, this is saying to go to this function, and again, when this is in here, it's saying, what's my function going to be worth? What's my output going to be worth when I look at the x value of 2? So if I go up here, here is my x is 2, and my answer is -4. So my function when x is 2 is worth -4. All right, so this is actually just the opposite. This is saying, if you just saw this, I'm asking for you to tell me what is x when f of x, when the function or the y value is worth 2. So I'm going to go back to that same function, and I'm going to look for where y is 2, which you can see here, and I get x, equals 3. I could also write this. My function, when the x value is 3, I got 2. So that's really a preference of yours. They are both correct. All right, next one, we're going to look at the function g of x. So this is saying, what is my function going to be worth when the x value is 1? So here I need to look at my graph. So remember, x always tells you to move left or right when you start at the center, at the origin. So I need to go to where x is 1. And then I either have to move up or down to find my y value, because y is, going up or down. And I need to go up to get to my shape. I can see it's right there, and that, again, is the coordinate 1, 2. So when x is 1, my y value, or g of x, is worth 2. So I'm going to write my function when x is 1 is worth 2. All right, so again, this is just the exact opposite. This is saying find x when g of x, or when y is 0. So y tells you to move up or down from the center, from the origin. So I'm going to grab a different color here. So this says, according to it being 0, that I shouldn't move up or down, right? So now to find my x value, I either go left to the shape or I go right to the shape. So I'm going to go right to hit this point, but I can go further right and hit this point. And again, this coordinate is 2, 0, and this coordinate is 4, 0. So when y is 0, you can see that x is 2. And you can see that x is 4. Whoops, sorry, you can't see that. X is 2 and x is 4. And you can also write it like this. My function when x is 2 is 0, and my function when x is 4 is 0. And again, you can see now that this is not one-to-one because y is repeating. And when y repeats, it can still be a function, but it's not a one-to-one function. All right, next one, -5. So we're going to go to the function m of x, and this is saying when x is -5. And so this is going to be a good review of absolute value. So I'm going to put -5 into here. And one really common mistake that's made with absolute value is we want to distribute. And we would distribute if it were parentheses, you know, we could do that. But absolute value bars are kind of like parentheses in the fact that we're going to do what's inside the absolute value bars. So we are inputting a number. We are following our order of operations. Please excuse my dear Aunt Sally. And again, parentheses, we're not going to distribute because these are really not parentheses, but these are absolute value bars. So if I have -5 and I take away one more, I'm at -6. And if you remember, absolute value is how far is the number from 0 on the number line. So you can kind of look up here, although I don't see -6. Let's say this is our number line, just the x-axis here, right? If I look at -6, how far is that from 0? Well, that's a distance of 6, and distance isn't measured as a negative number, it's a positive value. So absolute value is the overall distance of how far a number is from 0. And -6 is a distance of 6. So the easiest way to remember that is just the absolute value, when it comes out of the bars, becomes positive. All right, so now I'll do, that's a multiplication dot. So now I'll do my multiplying because there's no exponents. I get 12, and 12 plus 3 is 15. And the way I want to write my answer again is my function when my input is -5 is 15. So this is the better way to write it. All right. Okay, same idea. On this one, we're going to put 4 into that same function up here. So it's going to go 2, and then I'm going to have my parentheses of 4 take away 1. And again, I will look at the absolute value bars as my direction of what to do first, and I have 3. Whenever you take the absolute value of a number, it always is positive. This is positive already. So now I'm going to multiply. I get 6, and 6 plus 3 is 9. And so I'm going to write my function. When the x is 4, I get an answer of 9. All right, let's keep working through the functions. So this one is going to have 2 going into n of x. So I'm, again, asking myself, what's this function going to be worth when this x becomes 2? So it'll be 2 to the third power plus 1. And remember, 2 to the third power, that's not 6. That's 2 times 2 times 2. So there's 4. 4 times 2 is 8. 8 plus 1 is 9. So if I'm feeling a little lazy, I'll just go up here and do that. All right, now we're going to have a few challenge problems. So if you kind of compare this problem to this problem, this had us put -5 in for x, and this time we're going to put x plus 2 in for x. So here's the 2 in for x is going to be x plus 2. I still have the -1 and the plus 3. So again, all I did up here is I'm going to took this out and I put in x plus 2 in its place. Now I'm going to erase that because I might need this later. All right, so what can I do here? Well, I'm not going to get an answer like this, 15. I'm just going to clean this up as much as I can. So again, I will focus inside the bars first, and it's 2, and then there's my absolute value bar, and 2 take away is 1, and that's all I can really do. Here's my new function when x was replaced with x plus 2. So a little different, a little more abstract, but same idea. All right, in n, we're going to put an x squared here. So again, the x is just going to be erased, and in its place is going to be a little x squared. So x is gone, x squared is there, and normally all of that should be to the third power. And then I'm going to have plus 1. And again, if you remember, this just means that there's 3 of these. So an x squared times an x squared times an x squared. And then this means there's 2 x's, 2 x's, 2 x's. And if you look, you have 6 x's, x to the 6th. And then you have your plus 1, and that's as far as it can go. If you remember your exponent rules, that if you have the power of a power, you can actually just multiply those and get that 6 right there. So anyway, there's my answer, and I'm going to write it when x is replaced with x squared. So this is what I would write as my final answer. I'd probably put this first, the equals, and then that, but same idea. All right, let's move on to the next part. So we're going to start looking at something called piecewise functions. So this is just a very basic version, the intro to piecewise functions. So a piecewise function is just a certain type of function that's built from pieces of a bunch of different other functions. And it's going to be over different intervals, different x values. So you're not going to see a whole line, you're just going to see a certain piece of the line. So a couple things to think about as we do piecewise functions with evaluating, that if you see a closed dot, hold on one second. If you see a closed dot, you will include the x value, and it's similar to less than or equal to, greater than or equal to. If you see an open circle, then you will exclude or not include the x value. It's similar to less than or greater than, okay? And if you don't see a dot, it implies this one, okay? You really have to see that solid dot for it to include this. Like here, I mean, here we're showing you the dot, but normally they might not always put it there, but they will always make that noticeable. All right, so we've got our three functions, sorry. We've got f of x. So this is what a piecewise function would look like. Basically, instead of the whole line, I would just have a piece of it. So from here to here, and that is a closed dot. And then this is a quadratic equation, a parabola. And instead of all of it, I'm just going to have this piece of it, like this. Okay? All right, and if you notice, this is 2x plus 8. That's a line. That's something you learned in middle school in Algebra 1. And I should include the -2 value with it. So this closed circle is for the line. And I know that because for the x squared, which is a parabola, you learned that in Algebra 1, I don't want to include the -2. Okay, but that closed dot's like laying on top of the open dot. And in this function, I've got my line. I won't include 1, but for this part of the parabola, I will include the 1. And then that's g of x. And then we've got h of x. So we've got, h of x is -3. If you were to graph it, that's just a horizontal line. You've got another line of 2x plus 1, and you aren't familiar with this shape right now, but it kind of looks like this when you see a square root. Okay? And we're going to use -3. If our x is less than -4, we're going to use 2x plus 1. This is the same. If our x is -4, actually -4 because we're going to include it, all the way up to 5, but not including 5. And then we'll use this function if our x value is 5 or greater than 5 because it's underlined. So here we go. All right, first function. We're going to look at this function, f of x. So there's two ways I could do this one. One is I could go to where x is -2. So here's the y-axis, here's the x-axis. So I go to where x is -2. We're kind of highlighting this line right here. And remember, this dot includes this line. So I just want to look, and I really kind of went over that dot a lot, but what's the y value there? So it's over 2, up 1, 2, 3, 4. So I can tell just by looking at the graph that if x is negative 2, my y value is 4. Now, if you didn't have the graph, then I would look at the equation, and since it's negative 2, this equation is going to be used because x is including negative 2. So I can actually take the negative 2 and just plug it into here. 2 times negative 2, add 8, follow my order of operations. So I'm going to multiply. And when you add those, you get that 4. So sometimes there's 2 options to solve for it. It's just really up to you what you want to use. So on number 11, we're going to use g of x. So I only have the picture to look at. So I want to find what is x when the function or y is worth 4. So this is telling me, given y, I need to go up to 4. And I want it to include 4. So this point, because it's an open circle, this point 1, 4, I'm not going to use that one because I shouldn't include it. But if I keep going up and then I go over this point, because it's actually on that u, this point is 3, 4, will be my answer. So because this is an open circle, I won't use this one. You don't get to use it. But since this is actually on that partial parabola, we're going to say 3. And you can write it like this, or you could actually say, hey, the function when x was 3 gave me the actual y value of 4. All right, on number 2, I've got g of x. So this is saying when x is 1, I want to find the y value. So I'm going to go to where x is 1. And again, I got 2 options, so I cross this off. Let's bring it back. So we already know that this is 1, 4. And this point is 1, 0. So which one should I use? I should use the one where it is including the one, this closed dot, not the open dot. So my answer is 0. So my function when x is 1 is worth 0. All right, 13, I'm going to use h of x, and I should look to use the function where x is negative 10. So negative 10 falls in right here. Negative 10 is less than negative 4. And so based on this, I actually don't even have to use any math. This is saying when x is negative 10, my answer, no matter what, will always be negative 3. I don't have to plug it in here and do the order of operations. So the function, when x is negative 10, I get negative 3. Going back to the other one, 9, so the first one. So here I want to go to find x when y is 9. So I'm going to go, let's see. So again, when they give you y, that means from the center, from the origin, I want to go up, because y goes up or down, up to 9, and that's here. And again, we're only looking at the part that I've outlined with markers. So when I get to 9, I need to find x, and x tells me I should go left or right, and there really isn't anything here. You have to act like that dotted stuff's not there. But there is stuff to the right here, and it looks like that x value is 3. This is the point 39. So when x is 3, I get a y value of 9. So my function, when x is 3, I get 9. If you don't want to use the picture for it, then I'd look here and see where 3 falls into place. And it falls in here because 3 is greater than negative 2. So that means I should use this function, 3 squared. And again, 3 squared is just 3 times 3, and that gives you that 9. All right, last one. This function, I'm going to find h of x when x is 16. So here I have to see where does x being 16 fall. And it falls in here. 16 is greater than or equal to 5, so I'm going to come over here and use this function. So I'll be taking the square root of 16 and subtracting 2. And I should do the square root 4 first, and then 4 take away is 2. And I'm going to write my function as, when my x is 16, I get 2 as my y or my function answer. All right, so this will be mentioned on the Schoology page, but your practice is now, I'm on page 8, is to go through this whole thing. So basically you have to look at the function and decide, is what I gave you the y value or the x value? So here, this is saying f of x is 22. So this is going to be replaced by 22. And then your job is to isolate the variable, which we talked about in our first section of 1.1. Or actually, I'm sorry, we didn't talk about that. So let's just, remember, when you solve, you're going to isolate the variable. You're going to work backwards in the order of operations. And in this case, you would add 8, get a new number here, divide by 3, get your final answer. That is from middle school in Algebra 1. So when you see this, this is saying, all right, go into the function and make x4 to find your answer. So you would just do this, and I will let you actually do this math. And again, this is us inputting a number. You need to follow the order of operations. Do your parentheses, then your exponents, then your multiplying, dividing, then your adding, subtracting. Let's see here. Again, this is saying that x is 10. So based on this, which equation should I use, this one or this one? And then you plug the 10 in to whichever one it is and follow the order of operations. So just keep in mind that, and I think that's it. The next part is going to be in a second video.